Introducing Apex, an API broker solution to simplify data gathering and empower innovation. The world of business is more competitive than ever today, and telco is no exception. Operators must meet increasingly high expectations, but in an ever more cost-efficient manner. AI is looked at as a disruptive technology that can help meet this challenge. Data is central to this. Whether it is humans or a machine carrying out a function, they can only act on the data they can see. Better data means better context. Better context means better visibility and understanding. And better visibility and understanding allows for better management and control. Operators must particularly concern themselves with cost, efficiency, and quality. Operators that manage to embrace automation, AI, and other disruptive technologies can thrive in this evolving environment. The data we need to build better context is dispersed. It may be on other systems in our networks, it may reside in one of our roaming partner networks, it may reside somewhere else. Operators already cross-populate data between systems today, but not always in an efficient manner. APIs are a simple but powerful concept. They allow us to gather data from diverse sources. They allow us to automate that data gathering process. They allow for dynamic changes triggered between systems. They provide a common language for systems to communicate. And they can hide the complexities involved with communicating with a wide diversity of systems, interfaces, and data types. One area that could benefit from increased API usage is roaming. Today, roaming departments face many challenges. For outbound roamers, there is a need to ensure usage commitments are reached with roaming partners. Steering of roaming is used to enforce this, but there can always be issues with devices, coverage, or configuration that prevent us getting subscribers where we want. Today, operators may try to use the visibility they have to set realistic expectations for commitments, but in many cases, they are blind as to the underlying reason that they cannot get some devices to go where they want, making commitments uncertain. Managing quality is increasingly complex. There is now a huge diversity in types of customers, regular consumers, enterprise customers, and of course, IoT. And this is expected to grow with 5G. Many of these customer segments are quality sensitive. Today, operators may try to manage this through analytics they can see, but are limited as they cannot see everything that happens for a device in the visited network. For roaming departments, inbound roaming is a revenue stream. The challenge for operators is to attract this traffic from their roaming partners over other operators in the same country. Typically, operators try to compete for this share with more attractive commercial terms than their competitors or through differentiators like services and quality. Finally, handling of complaints is an inefficient and resource-intensive process. This could be complaints from our own roaming customers, where we depend on the roaming partner's support to resolve these, which is not ideal. Or there could be complaints from our roaming partner, in which case we must spend time and effort assisting them. The primary challenge introduced by roaming in general is the loss of visibility and control. In the home network, we have total control, but when subscribers go roaming, some of this is lost. What we need is more context, and APIs can facilitate this. Where we cannot get all of our traffic onto our preferred roaming partner network, we want to understand why. To help with this, we want more context. The location of my subscribers that are in the wrong network. The device types being used by subscribers in the wrong network. Technical failures impacting my subscribers. With this additional data, we can better set achievable targets and use this data in negotiation with our roaming partner or in feeding forecasting systems. The data may also enable us to work proactively with our roaming partner to resolve technical issues, which benefits both parties. When subscribers are on the home network and face an issue, we can check all the logs and find the failure cause easily. When roaming subscribers have problems, there are some failures that will occur entirely on the roaming partner network that we, as the home network, have no visibility over. We could better determine issues impacting our subscribers by filling in these visibility gaps with data from our roaming partner. Along with this data, information like location, device type, and type of customer enable us to better understand and manage roaming quality issues. Complaints between roaming partners fundamentally revolve around this same data. Today, multiple parties, the home and visited networks, hold parts of the data that give us a complete picture of what a roaming device is doing and how it is impacted. If this data required to troubleshoot an issue could be easily centralized in the home network, this would be in everyone's interest. An API call could be used to retrieve this data from the roaming partner. The home network could independently and immediately troubleshoot issues their subscribers face, and the visited network does not need to spend time and effort investigating the case. Operators taking this approach of empowering their roaming partners to independently investigate issues through APIs provides benefit in a number of ways. They reduce their own overheads, making management of the roaming partner relationship less expensive, and in turn allows them to better compete on price. And they provide a much better service to the roaming partner than they have today, enabling them to better compete on quality. A roaming partner with quality-sensitive segments amongst their roamers will prefer to have these devices roaming in a network that gives them access to better data, which better enables them to manage their own customers. In these examples, we can see the value that can be brought by creating better contextual awareness, enabled by data enrichment from roaming partners and various other sources. This same idea could be reapplied for countless other systems and use cases, some of which we cannot yet even imagine. To realize this, we need to make it easy for any system to gather data from any data source, now and in the future. This is where Apex comes in. Apex is a single point in the network that can communicate with any other system, either inside or outside the network. It speaks multiple languages. This could be REST, SOAP, GraphQL, or could even be signaling messages using protocols like MAP or Diameter. In essence, these are just calls to remote systems, the same as other API types. Every system in the network need not communicate with every other system from which it needs to get data. It can just speak a single language and let Apex manage the complexity of communicating with other systems on its behalf, making it simple for any system to get involved in this data sharing. Here we can see a demonstration of the difference in visibility in the home network versus the visited network. The home network has visibility of anything sent back to it, but does not see any points of communication that exist entirely in the visited network. The visited network has complete visibility. As the home network, we want to get this same visibility. Let's look at how we get it. We would like more detailed location information about our subscriber. We can request the data from an API offered by our roaming partner, or if they do not offer this, we could use a map or diameter query. The API call from our system to Apex is always the same. It does not care how Apex gets this information. The location we get back may get us the location only to a cell ID level. We can further enrich this with an API call-out to a third-party cell ID database to retrieve GPS coordinates. We may also want to learn more about the device. These could be queried from a device database to learn the device type, and the GSMA device compatibility database could also be queried to check device and network compatibility. And we may also retrieve the raw logs about our roaming subscriber through another API call to our roaming partner, giving us full visibility on what has happened with our subscriber on their network. In all cases, the API call from the system requesting the data is a simple request to Apex. Apex hides all of the complexity of gathering the data. Imagine we are looking at our steering system and we check how we are performing in the US. In this example, we would ideally like all of our traffic to be on a single network. In this case, we see that we have almost 10% of our subscribers in the wrong network. We would like to find out why this may be the case, to see if we can resolve it, or at least understand the underlying reason and manage it. We use the API calls previously described to gather this extra data. Our map shows us the locations we have retrieved for all of our subscribers in the US. Marked in red are any subscribers that are not attached to the network we want. We want to find what these subscribers have in common. One commonality we can identify is geographic. If we zoom in on a cluster of red data points, we can see that all of our subscribers around this area of Fort Myers, Florida, are on the wrong network. This would point to a likely coverage issue. But not all failures are geographic. Another data point to consider is the device type. If I check my different device types, I can see that my Google Pixel 7 is always on the wrong network. This could indicate that there is a compatibility issue between this device and the preferred network. Then there are other subscribers with no immediately discernible reason as to why they are on the wrong network. For these, we want to be able to look a little bit deeper to see if we can find any other reason they may have not been able to attach to our preferred network. Here is one such subscriber in Scranton. We have a full picture of this subscriber from our own local logs, combined with the information we received from the partner network. We can see in this case that they did attempt to attach to our preferred network, but they had a failure connecting to the MMME and subsequently moved to a different network. We can see the error cause for this, and we can use this to determine if this is a configuration issue or a technical error on the other network and take appropriate action either ourselves or in conjunction with our partner network. It is in both parties' interests for this subscriber to be able to attach successfully. We may also use this view to look for commonalities in technical issues. We can filter this report to just show us the failures. We can see overall the type of failures that are occurring, and again, we can look for commonality such as device type to help better understand the potential cause of the issues. We can easily see how this enhanced context provides us a far superior capability to identify issues and in turn resolve them. Just as we have looked at a basic analysis and manually drawn some conclusions here, an AI system could easily replicate this process to interpret this data, find the commonalities, and automatically report or resolve. And it could do it in a faster, efficient way, freeing up our technical resources for more valuable work. The benefit to the home network is clear. But what about the case where we are the visited network? What is in it for us as the visited network to provide this data to our roaming partner? Firstly, this enables our roaming partner to independently troubleshoot for their own roamers without wasting our resources investigating. They also benefit by being empowered to solve problems on their own without dependency on the visited network and their people. Secondly, we can expect the same in return, and we can benefit from better visibility and control of our own roamers through a reciprocal agreement. Thirdly, it enables us to compete for inbound market share based on differentiation on quality. By providing this enhanced visibility to our roaming partner via API, we become a more appealing roaming partner for them to send their traffic to over other networks which may not empower them in the same way. There are some relevant parallels in the industry from the past and today. NG116 already imagines the gathering of logs from networks in 5G. This is intended for enterprise consumption, but could equally be applied to roaming partners and legacy technologies like LTE. Many years ago, operators created NRTRDE for faster sharing of usage information to combat roaming fraud, which became de facto mandatory. Operators would simply not want their roamers to roam on a network where fraud was likely to occur without them knowing about it. They would rather send their subscribers to a network where visibility through NRTRDE was provided. We can see quality through the same prism. Operators will prefer to send their traffic to the network that provides them better visibility and control of their quality-sensitive customers. The other relevant parallel is Open Gateway. The technology for enabling API exposure is the same, but the use there is focused entirely on enterprise-to-operator APIs. A similar approach for operator-to-operator API standardization could be taken to enable consistency of communication across operators, consistency of data, and as such, enable scalability of services offered by API between roaming partners. Operators could implement standardized interfaces and offer these as services to their roaming partners, allowing for the same communication and outcome regardless of roaming partner. Ultimately, we need to aim for maximum context. This context enables better visibility, better control, better efficiency, and opens the door for AI to bring new value. APIs are the key to building these datasets, for getting this context. Simplification of the data gathering process is essential. Apex empowers any system that could benefit from additional context to get it. Any system can request any information through a simple, basic communication with Apex or provide data via Apex. Apex hides the complexity. It talks all the languages used by various systems. It mediates the data received back to make it look like it needs to. It provides access to data both internally and externally. Apex empowers operators to embrace automation and can drive innovation.